To show you the fundamental principles underlying the working of dialysis membrane. So the main phenomena which takes place in dialysis, especially in the dialysis membrane, is are two things. One is diffusion and ultrafiltration. So what is diffusion? It's the exchange of things dissolved in the fluid. So fluid, the solutes across the membrane due to difference in the amount of solids in two sides, called concentration gradient. So what is that? I have a large number of solutes here, less number of solutes. So the movement of solutes from the higher concentration side to the lower concentration side is called diffusion. If there is a higher concentration of a given one side of the membrane than on the other, then the diffusion will occur. Try to make the concentration on both sides an equilibrium or at the same level. By controlling the chemicals in the dialysis machine controls this transfer of solutes across the membrane. Okay. So there is another technique called ultrafiltration. So ultrafiltration is a convection, is also referred to as convection, is the fluid flow through the membrane forced by a difference in the pressure on two sides of the dialysis. In the previous method it is called the concentration gradient, but here it is a pressure gradient difference in the pressure. This controls the patient's weight loss over the course of treatment. Why weight loss? Because in this process of dialysis, there is a movement of solutes in and out of the body, resulting in the weight loss of the patient. Okay, while the earlier dialysis machine either control the dialysis pressure or difference across the membrane in order to achieve ultrafiltration. Modern dialysis are generally volumetric, meaning they control the volume of the fluid. So previously they control the pressure, now they control the volume of the fluid removed from the patient directly, allowing the dialysis patient to change as it will in order to achieve the prescribed weight loss. Okay, so you all know that pressure and the volume are related in several ways. So thereby controlling the volume, you can thereby control the pressure. Okay, and at last entering the weight loss. Okay, so dialysis membrane has perforations which are extremely small and are invisible to naked eyes. The waste products in the blood are able to pass through this minute perforation to dialysis fluid, from where they are immediately washed away. In dialysis, the blood is exposed to dialysis solution across a selectively permeable membrane, which allows lower molecular weight compounds to move freely between the two solutions but restrict the passage of larger molecules such as proteins. The perforation in dialysis membrane have an average membrane of 50 angstrom units, estimated between 30 to 90. The waste products pass through the membrane because the existence of concentration gradient. The dialysis fluid is free of the waste product molecules. Therefore, the blood would tend to distribute themselves evenly throughout the blood and the dialysate. So the waste product goes into dialysate, so dialysate solution, and it is removed thereafter. So these are the two, and you can see in this diagram very clearly. Red corpuscles cannot pass, these are sugars cannot pass, proteins cannot pass, waste. Okay, sugar and salt. Okay, so there are like small sugars. What I mean by sugars cannot pass is larger carbohydrates cannot pass. Small sugars and salt in turn can pass through this solution. Okay, so very simple. There's the molecules that are of the lesser than the size of the dialysate membrane perforations can pass through them. Okay, large molecules cannot pass through them. Okay, so this from blood to the dialysis is in the cleaning, the results in the cleaning of the blood. The volume of the blood fluid cannot be controlled by dialysis. Instead, ultrafiltration across the membrane is employed. Okay, for this, a positive pressure is applied to the blood compartment, or a negative pressure is established in dialysate compartment. Either way, the fluid, both water and the electrolytes, will move from the blood compartment to the dialysate, which is subsequently discarded. The degree of ultrafiltration depends on both on the pressure difference across the membrane and ultrafiltration. Okay, so this is the fundamental process underlying a dialysis membrane. Okay, so if it is asked in the exam about importance of fundamental principle, these are the fundamental principles. What are those? Diffusion and ultrafiltration. Okay, thank you.